Hello students, today our topic is motion in a straight line, or most probably today we will discuss about the motion. This is a topic which is there in the class 9 CBSE portion and as well as class 11 portion also. So I will just cover from basic to advanced level this motion topic. So let's start. Whenever we are discussing about motion, the first thing we should think, what is motion? Now whenever we are talking about what is motion, first thing you have to know with respect to whom we are talking that. With respect to whom we are telling that we are in motion not. So let's start. Suppose this is a car. Here whenever we are talking that this is a car and this is moving, or I'm telling this is a car, this is moving. Now if I'm mentioning that inside this car whoever is there, he is in motion with respect to a tree which is stationary. With respect to a tree which is stationary means at rest. Now if the car is in motion with respect to a tree which is at rest, then we can say that this car is in motion. That means whenever we are discussing about anything to be in motion, we need to mention that with respect to whom it is motion. Suppose here the tree, this thing is what? The tree is in rest. With respect to tree, the car is moving. So with respect to this surrounding, the car is in motion. But suppose I'm telling that a person, he is standing with respect to this tree. With respect to this tree, the person is at rest. But at the same time we can say that the person is at rest with respect to tree, but with respect to the sun, here sun's reference frame, as the person is inside the earth, if the person is inside the earth, with respect to sun's reference frame means anybody sitting over the sun, the person is not in rest, the person is in motion. That means we can say an object is said to be in motion if it changes its position with respect to its surroundings with the passage of time. For example, a train moving on rails. Means the object which can be said to be in motion if it is changing its position. If it is changing its position with respect to the surroundings, that means that car is changing its position with respect to that tree. And if the object is said to be at rest, if it does not changes its position with respect to its surrounding, then that will be at rest. Means suppose we can tell that suppose somebody is sitting, with respect to whom they are sitting, with respect to a standing person or with respect to a tree or with respect to the surrounding, if it is not changing its position, then we can say that they are at rest. But if with respect to the surrounding, if they are at not rest, with respect to the surrounding, if they are at not rest, they are changing their position in the passage of time, then we can say that they are in motion. Now one more thing we need to know, that rest and motion, this concept, these are not absolute. These are not absolute concept. You may ask why. What does it mean that absolute? Suppose I am telling that sun rises in the east and sun sets in the west. Is it absolute? With respect to Earth's reference frame, this is absolutely true that sun rises in the east and sun sets in the west with respect to Earth's reference frame. But whenever I am telling this car is in, this man is at rest. But this man is at rest with respect to whom? With respect to this tree. But at the same time, if the man is at rest and the person who is sitting inside this car, what will see this man? He will see that this man is seemingly moving or appears to move. That means with respect to a man who is sitting over the tree, or with respect to a monkey who is sitting over the tree, with respect to that monkey or person, this man is at rest. But with respect to a man sitting over this moving car, this man is not at rest. This man is seemingly moving. That means we can't say that anything is absolute at rest or anything is absolute motion. We cannot say that. That means rest and motion are relative concepts. Means you can see here they have written a passenger is sitting in a moving train is at rest with respect to the fellow passenger, means someone who is sitting inside the train. Now those passenger who are sitting along with them, with respect to that fellow passenger, that passenger is at rest. But someone who is outside the moving train, with respect to that person, they're not at rest, they're at moving. That means we cannot say absolutely that a body exists in absolute rest or absolute motion. That means rest and motions are relative concepts. They are relative. Now we have to know about the concept of point object or point like object. What is point object? Let's take an example. Suppose an object is at position A. Now what will be its dimension? The position of the object, now what will be its dimension? Very less. We are assuming it very less. Now what will be the point object? Point object is that if the position of this object changes by great distance that much greater than its own size, means this is the point object, this is the position x. Now this object changes its position means the object is at that position. I'm drawing again. This much dimension, the point object has this much dimension. Dimension means it has this much length. Let me focus it clearly. Yes, this much size, point like size, and its position is changing like this. Now the length of this or the distance of this position change is much greater than its size. If the distance change or the distance changed by the position of the object is much greater than its size in a reasonable duration of time, then it will be termed as point object. Means suppose an object, suppose earth can be regarded as a point object if we are studying the motion of sun, motion around the sun, if we are studying the motion around the sun. Now the changes of position taken by earth is much greater than its size. That's why earth can be regarded as a point object studying its motion around the sun. Now let's study the point object. Let's take the definition of point. Means if the position of an object changes by distances much greater than its own size in a reasonable duration of time, then the object may be regarded as a point object. Means the position of the object will be changed greater than its own size. Suppose earth is revolving around the sun. Now these changes of position of the earth is much greater than its size. In that respect, we can say that earth will be termed as a point object. Similarly, see, a train under a journey of several hundred kilometers regarded as a point object. Why? Because whenever train is changing several hundred kilometers length, but the size of the train is itself nearly about 80 to 100 meter, approximately in general I am saying. So considering that motion of several hundred kilometers, we can say that dimension of the train will be much smaller than that 700 kilometer distance position changed by the object. Means the train has taken several hundred kilometers distance. Train has changed several hundred kilometer path, but the dimension of train is very much small. With considering that several hundred kilometers path. So with respect to that term, we can tell that train will be termed as point object or point like object. That's it. Now in this motion we'll discuss the one of the most important concept, distance and displacement. Before coming to the definition of distance and displacement, we will be first considering with some example that what can be termed as distance and what can be specified as displacement. Let's take an example. Suppose here a student, he is starting from his or from her own house, the point A. When the student is starting from his or her own house, now he has gone to school. Here the student has gone to school. Now the student may go to school in this way. He may take the school in this way. He may go to the school, he or she may go to the school in this way also. Now there are infinite number of paths that the students may take from going from point A to B. Now the distance traveled by the students, now this is the path A, path B, path C, path D, path E. Now whenever the students are traveling from A to B, the students are traveling from A to B path. This. In each case A, case B, case C, case D, case E, in each case, the distance or the length traveled by the students or the length covered by the students are different. From A to B, if the student is following the path A, in that case distance will be different. If the case B, the student is following the path for the case B, then the distance will be different. Then what is distance? Distance is nothing but total length. Distance is what? The distance traveled by body is the actual length of the path covered by a moving body. I'm saying the distance traveled by a body is what? The actual length of the path covered by a moving body. That means if a body is in motion and if that body is covering somewhat length and some length or some covering some actual path length, that total actual path length covered by the moving body, irrespective of direction in which the body travels, means irrespective of direction means the body will travel in this direction, the body will travel in this direction, the body will travel in this direction, in this direction, in this direction, whatever direction he is traveling, the body is traveling. Irrespective of the direction, how much path length has been covered by the body, that will be termed as length. That actual path length will be termed as distance. Then what is distance? The actual path length covered by a moving body, and irrespective of direction of motion in which the body travels. You can see one example has been provided here, that a body is traveling from A to B. First the body has traveled in this direction A to B. How much distance? 5 km. Okay. Then the body traveled from distance B to C. How much distance? 3 km. First the body is traveling here A to B, then B to C. Then total distance will be what? Total distance will be 5 plus 3, 8 km. So what we got to know, that distance is nothing but the actual path length covered by the moving body, irrespective of direction of the body which it travels. But whenever we are discussing about the distance, here no direction is mentioned. As here no direction is mentioned, we can say the distance traveled is scalar. Whenever we are discussing about the distance traveled is actually scalar. Now, whenever we are telling about distance, then immediately another concept will come, that is displacement. Now, whenever we are discussing about displacement concept, let's draw a diagram again. This is point A and this is point B. Suppose this is your home and this is your school. Now whenever you are going from A to B like this way, you are going from A to B like this way, you are going from A to B like this way, you are going from A to B like this way. Now what might be the shortest path? Can you tell? The shortest path will be this straight line. Now whenever we are discussing about the displacement, what we are discussing about displacement. Whenever we are discussing about the displacement is nothing but the shortest path. Here we are giving the path name A to B. We are path 1, path 2, path 3, path 4, path 5. 5 paths are available here. See, look at here. Here there are 5 paths available for moving from A to B. When there are 5 paths available, so what you can tell? Okay, so we can go by any of the path 1, 2, 3, 4, 5 paths. But suppose you want to go very quickly at the point B. Now you are searching for the shortest one. You are searching for the shortest path. So what would be the reasonable path for you to reach that point B at a short time? Now whenever you can see that among these all 5 paths, number 4 paths are the shortest one, this straight line. That means what we can say, that displacement is nothing but shortest distance. Displacement is nothing but the shortest distance between the initial point A, final point B. So if we will look after the, what is that? If we look after the definition, what we will get? Let's see. See here, we can see when a body moves from one point to another, distance traveled refers to actual length of the indirect path, that is the distance, but displacement refers straight line path. That means what is displacement? When a body moves from one position to another, the shortest path, that straight line path mentioned here, shortest distance between initial position and final position along with direction. Here you need to know that displacement has a direction, a certain direction, a proper direction. That's what we can call displacement as a vector quantity. We can tell displacement as a vector quantity because suppose I am telling a student is going from A to B 25 kilometer, and but I'm not mentioning a certain direction, but I am telling the person is going A to B 10 kilometer along eastward in a certain direction. That would be the shortest path and that would be the displacement. So what should be the definition of displacement? When a body moves from one position to another, the shortest distance between initial position means starting position and final position along with the direction is known to be the displacement. For example, you can take this example too. If you see this example, as we discussed that if the person is going from A to B, 5 kilometer he has gone, then B to C, 3 kilometer he has gone. Total distance is 8 kilometer. But what will be the shortest path? A to C. The displacement will be 4 kilometer. Now you might be asking why. That Pythagoras theorem, that if it is perpendicular, if it is base, and it is suppose if it is perpendicular, it is base and it is hypotenuse, perpendicular square plus base square equals hypotenuse square. Now the base I want to calculate, the base equals hypotenuse square minus perpendicular square. So in case it would be 5 square minus 3 square, that means 25 minus 19, that means 16, that means 4 kilometer. That means displacement is that shortest one path that will be traveled by the body from one position, initial position to final position. The another proper formula of the displacement is, you can tell, which might be helping you out during your study that displacement equals final position minus initial position. Yeah. What is displacement? Displacement is final position and final position minus initial position. Now, whenever we are discussing about distance and displacement, some points you need to mention. That already we have discussed that distance is a scalar quantity. Scalar quantity means distance has no direction, no specified direction. It has magnitude only. But displacement, as we know, it is a vector quantity, means it has both magnitude and direction. Another most important point you have to think. What is that point? Suppose you are traveling from A to B. This is your school and this is your house. Suppose this is your house, there is your school. A is your house, B is your school. Now what you will tell? Okay, during the morning 7 a.m. you travel from your house and you reached at your school. Okay, and during 12 o'clock, 12 noon, you are returning back from your school to your house. Now here you might be conscious. Your initial position was your house and final position was your school. When you are starting from your house and reaching to your school, you have covered certain distance. Then you are turning back from your school to your house, you have covered some distance. So as you have covered some distance, so distance is not equals to 0. Here, distance is non-zero. The thing you can mention here the distance will never be 0. But whenever you are telling initial position and final position, and as we are seeing this formula, final position minus initial position, you can see at the end of the day you are reaching back to your house only, means you are reaching back to initial position. That means your final position and initial position both are same. That means displacement is 0. That means what we can conclude? Distance can never be 0, but displacement can be 0, can be positive, can be negative too. You might say why? If final position is greater than initial position, the magnitude of the final position is greater than initial position, in that case displacement positive. The magnitude of final position and initial position both are same, as you see in this case. In that case displacement will be 0. And if the magnitude of final position is less than the initial position, in that case the displacement will be negative. That's all. That's all about displacement. Now we will discuss the displacement for circular path. Now whenever you are covering from A to B, that means what? You are covering a radius, you are covering a circle of radius r. Whenever, suppose you are jogging around a circular park, you are jogging around a circular park, and what happened on a very funny day, on a very sunny day, whenever you are jogging around that circumference of the path. Whenever you are jogging from A to B, suppose this is B, again you are traveling to A, means you are completing one full round trip. Whenever you are completing full round trip of a circular path, in that case you are covering whole circumference, means whole boundary of the circle. In a circular ground, you are covering one complete cycle. That means you are covering whole boundary of the cycle. In that case, you are covering circumference. And what is the formula of circumference? 2 pi r. That means if you are covering that whole circular path, that means you are covering total distance how much? 2 pi r. But as soon as you are reaching to that position A, from starting position A, you are reaching to the position A, your initial position and final position are becoming same. As soon as your final position and initial position are becoming same, your displacement will be 0. That means in covering a circular path, a full trip, in a final complete path, distance is non-zero but displacement is 0. Same things you can take. One questions you let me know in the comment section. What if? In the comment section you let me know what if we will travel from A to B. That means we are covering semicircular path. What would be the distance? What would be the displacement? Thank you.